In 1887, two scientists proved that everything we knew about light and motion was wrong. The Michelson-Morley experiment was supposed to measure Earth's movement through the ether, the invisible substance scientists believed filled all of space. They built the most precise measuring device ever created. They ran the experiment hundreds of times. The result? Nothing. Zero. The ether didn't exist. The entire foundation of physics collapsed overnight. But here's what should terrify every scientist. That experiment didn't just disprove one theory. It broke the fundamental laws of how motion and light were supposed to work. The results were so impossible that physicists spent 18 years trying to explain them away before Einstein finally accepted reality and rewrote physics with special relativity. These are 5 experiments that produced results so impossible they shattered the laws of physics, forced scientists to rebuild entire fields from scratch, and revealed that reality operates in ways that seem mathematically impossible. The double-slit experiment, particles that know they're being watched. In 1801, Thomas Young fired light through 2 narrow slits onto a screen. Basic physics said light should create 2 bright lines, one behind each slit. Instead, he got an interference pattern, alternating bright and dark bands. This only happens with waves, not particles. Light was behaving like a wave. Same result. They added detectors at the slits to see which one the electron went through. The moment they added detectors, the interference pattern disappeared. The electrons went through one slit or the other, like normal particles. Remove the detectors, the pattern came back. The particles knew they were being observed. That's not metaphorical. The act of measurement changed the electron's behavior. Each electron exists in superposition, passing through both slits simultaneously. It chooses one path. This violates every law of classical physics. Objects don't have different properties depending on whether you're looking at them. Niels Bohr said, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it." This experiment proves why. Reality at the quantum level doesn't follow the rules of reality at our scale. Observation isn't passive. It fundamentally changes what's being observed. The Copenhagen interpretation says the electron genuinely exists in multiple states until measured. The many worlds interpretation says the universe splits into parallel versions for each possible outcome. Both explanations sound like science fiction. Both are taken seriously because no other explanation fits the data. This experiment broke the law that objects have definite properties independent of observation. It forced physics to accept that reality itself is probabilistic and observer-dependent at the quantum level. Quantum entanglement. Einstein's spooky action at a distance. In 1935. Einstein proposed a thought experiment to prove quantum mechanics was incomplete. If you create 2 entangled particles and separate them by any distance, measuring one particle instantly determines the state of the other, even if they're on opposite sides of the universe. Einstein said this was absurd. Information can't travel faster than light. He called it spooky action at a distance and thought it proved quantum mechanics was wrong. In 1982, Alain Aspect actually did the experiment. He created pairs of entangled photons, sent them in opposite directions, then measured their properties. Measuring one photon instantly determined the other's state, regardless of distance. The correlation was perfect and instantaneous. Physicists immediately looked for hidden variables, some unknown property that determined both particles' states in advance. John Bell had proven mathematically that if hidden variables existed, the correlation between entangled particles would be limited. Aspect's experiment violated Bell's inequality. The correlation was stronger than any hidden variable theory allowed. The particles weren't predetermined. They were genuinely connected in a way that transcended space. Here's what this means. You measure a particle in New York. Its entangled partner in Tokyo instantly knows and adjusts its state accordingly. Not after light speed delay. Instantly. This doesn't transmit information. You can't use it for faster-than-light communication. But it proves that entangled particles aren't separate objects. They're a single quantum system regardless of spatial separation. This breaks the law of locality, the principle that objects are only influenced by their immediate surroundings. Einstein built relativity on locality. Quantum mechanics violates it. Both theories are experimentally confirmed. Physics hasn't reconciled this contradiction. The 2022 Nobel Prize in Physics went to Aspect and two others for proving entanglement is real. After 40 years of experiments, quantum entanglement is now the foundation of quantum computing and quantum cryptography. We're building technology based on a phenomenon that Einstein insisted was impossible, the Casimir effect. Energy from nothing in 1948, Dutch physicist Hendrik Casimir predicted something impossible. Take two uncharged metal plates, bring them very close together in a vacuum, and they'll attract each other, even though there's nothing between them to create force. Classical physics says this can't happen. A vacuum is empty space. No particles, no fields, no forces, but quantum field theory says vacuum isn't empty. It's filled with virtual particles constantly popping in and out of existence. These particles exist for fractions of a second before annihilating, borrowing energy from the universe in a way that doesn't violate conservation laws because they pay it back instantly. Casimir said the plates would restrict which virtual particles could exist between them. Only particles with wavelengths smaller than the gap could appear. Outside the plates, all wavelengths are allowed. This creates a pressure difference, more virtual particles pushing from outside than inside. The plates should attract. You can't measure forces from particles that don't exist. Steve Lemoreau measured it. He placed two plates, 1 micron apart, and detected the exact attractive force Casimir predicted. The vacuum was generating real, measurable force from quantum fluctuations. This breaks the law of energy conservation. Kind of energy appears from nothing, does work, moving the plates, then disappears. Except quantum mechanics allows this through the Heisenberg uncertainty principle. Energy conservation can be violated for infinitesimally short times. Virtual particles exploit this loophole trillions of times per second in every cubic centimeter of empty space. The Casimir effect proves the vacuum isn't empty. Space itself is churning with quantum activity that classical physics says shouldn't exist. We're now researching whether this vacuum energy could be harvested, extracting power from nothing. Quantum tunneling, particles that walk through walls. Classical physics says if you throw a ball at a wall, it bounces back. The ball doesn't have enough energy to break through, so it can't. At the quantum level, this law is a suggestion. In 1928, George Gamow used quantum tunneling to explain radioactive decay. Alpha particles are trapped inside atomic nuclei by forces stronger than they can overcome. Classically, they should stay trapped forever. Instead, they occasionally appear outside the nucleus, as if they walked through the barrier. Here's the mechanism. Quantum mechanics describes particles as probability waves. Most of the wave is on one side of the barrier, but a tiny portion extends through to the other side. Usually, the particle stays on the high probability side. Occasionally, purely by chance, it manifests on the other side. From the particle's perspective, it tunneled through a barrier it didn't have energy to cross. In 1981, Gerd Binnig and Heinrich Rohrer built the scanning tunneling microscope based on this effect. They brought a metal tip incredibly close to a surface, close enough that electrons could tunnel between them. By measuring the tunneling current, they could map surfaces at atomic resolution. This technology won the Nobel Prize and revolutionized nanotechnology. But here's what makes this impossible according to classical physics. The particle doesn't gradually push through the barrier using energy. It doesn't drill a hole. It probabilistically exists on both sides, then collapses to one side. It teleports. The barrier is a definite obstacle with definite energy requirements. The particle ignores both and appears on the other side anyway. This breaks conservation of energy temporarily. During the tunneling process, the particle has less energy than required to be where it is. Quantum mechanics allows this violation for time frames so short that Heisenberg's uncertainty principle permits it. Borrow energy, tunnel, pay it back instantly. Your body contains atoms. Those atoms undergo quantum tunneling constantly. There's a non-zero probability that all your atoms could simultaneously tunnel 3 feet to the left, teleporting you instantly. The probability is so unimaginably small, it will never happen in the lifetime of the universe, but it's not zero. Quantum mechanics says spontaneous teleportation is possible, just really, really unlikely. Time crystals, matter that moves without energy. In 2012, Nobel laureate Frank Wilczek proposed time crystals, a phase of matter that repeats in time the way normal crystals repeat in space. A salt crystal has a structure that repeats every few atoms. A time crystal would have a structure that repeats every few moments, oscillating forever without energy input. This violates thermodynamics. Perpetual motion is impossible. Everything moves toward equilibrium. A pendulum swings, but friction eventually stops it. You can't have a system that oscillates forever without adding energy. Time crystals do exactly that. In 2017, 2 teams created time crystals in the lab. They used chains of ions manipulated with lasers and magnetic fields. The ions flipped their spin states in a repeating pattern, not at the frequency of the laser pulses driving them, but at half that frequency. They were oscillating independently at their own rhythm, sustained indefinitely. Here's why this seemed impossible. Time crystals exist in their ground state, the lowest energy configuration. They can't lose energy because they're already at the minimum. Yet they move. Classical physics says objects in ground state are static. Time crystals in ground state oscillate. They break time translation symmetry, the law that says physics works the same at all moments in time. Normal crystals break spatial symmetry. Atoms arrange in patterns rather than distributing evenly. Time crystals break temporal symmetry. They create patterns in time rather than maintaining equilibrium. Physics had assumed time symmetry was fundamental. Time crystals prove it can be broken. The practical implications are staggering. Time crystals could store quantum information indefinitely without energy input, perfect for quantum computers. They could be quantum batteries that never discharge. They're a new phase of matter that shouldn't exist according to thermodynamics, but does anyway. What these experiments actually mean: every experiment on this list produced results that were mathematically impossible according to established physics. Scientists didn't just make mistakes. They carefully verified, replicated, and confirmed results that violated fundamental laws. The double-slit experiment destroyed the idea that observation is passive. Reality at quantum scales is observer-dependent. The universe doesn't have definite properties until something measures it. Quantum entanglement destroyed locality. Objects aren't isolated by distance. Entangled particles are a single system regardless of separation. Space doesn't separate everything the way we thought. The Casimir effect destroyed the idea that vacuum is empty. Space churns with quantum fluctuations constantly. Nothing is actually something, and it generates measurable forces. Quantum tunneling destroyed energy barriers as absolute limits. Particles probabilistically ignore barriers they shouldn't be able to cross. Classical impossibility becomes quantum improbability. Time crystals destroyed time translation symmetry. Objects in ground state can still move. Perpetual motion is possible in quantum systems under specific conditions. But here's the pattern. Each experiment revealed that classical physics, the intuitive, everyday physics that governs our visible world, is an approximation. It works at human scales, but breaks down at quantum scales. The universe operates on rules that seem mathematically impossible to us because our intuition evolved in a classical environment. Physics didn't break. Our understanding of physics was incomplete. These experiments force scientists to expand the laws of physics to include quantum mechanics, a framework where observation affects reality. Particles exist in superposition. Entanglement transcends space. Vacuum isn't empty. And barriers are probabilistic rather than absolute. We're now building technology based on these impossible phenomena. Quantum computers exploit superposition and entanglement. Scanning tunneling microscopes map atoms using tunneling. Quantum cryptography uses entanglement for unbreakable encryption. We've gone from "this can't be real" to "this is the foundation of 21st century technology" in less than a century. The experiments that broke physics didn't destroy science. They revealed that reality is stranger, more complex, and more interesting than anyone imagined. The laws of physics aren't broken. They're bigger than we thought. And every time we probe deeper, we find new phenomena that seem impossible until we understand them. That's 5 experiments that shattered fundamental laws of physics and forced scientists to rebuild our understanding of reality from scratch. The universe doesn't care about our intuitions. It operates on rules that seem absurd until we test them and find out they're exactly how reality actually works.